video is to explain how to use the program ratio, which is an Excel-based program. The purpose of ratio is to be able to calculate the value of voltage divider resistors using standard value resistors. Standard value resistors, for the most part, are usually the 1% and come in 96 parts per decade. There's also the 0.1% resistors, which come in 192 parts per decade. So what we're going to do here is have a voltage divider, and it may look a little funny at first, but bear with me. We have V1, V2 feeding 3 resistors. The main purpose of this is to design some voltage dividers for power supplies where you're going to put a small amount of resistor over here in R1 so you can do control loop testing. However, for a standard voltage divider, R1 is going to be equal to 0, and then V2 will probably be 0, and V1 is going to be our normal input voltage. So let's see how this works. Let's suppose that we wanted to take 5.1 volts, V2 is 0, and V out is going to be 3.3 volts, R1 is going to be 0, and now we have the maximum tolerance. This is the maximum band that you're going to allow V out to go through, and normally you can start with like 1%, and that is in a percent. We are going to be using 1% value resistors, so we put a 1 here. The series resistor, we'll go over that in a subsequent video about what to do with this number, and also the I bias. The tempo of the resistor, max temperature, and the min temperature you can put in. The program will calculate the min and max output voltage based on tolerance and temperature for that resistor. So once we get our numbers in, then we can click OK, or left click Start, and we see we get a family of resistor values. Notice R1 is 0. That's our little sense resistor, if you will. R2 and R3 start going up in value. One of the things that you may want to watch for is the power rating for these resistors. Now, so what that means is we're not going to probably use 1 ohm and 1.87 ohms for this circuit, because the resistor power dissipations are going to be about 3 watts and 6 watts for those two. So that may not be a good choice. So we start scrolling down, and we see we have a lot of values that will work, and we have various tolerancing on the output voltage. We'll go over that in just a second. So we get down here, and we get down to the k ohms, and let's see, we like to be around 10 k ohms for our voltage dividers. So we see we have a 10k and an 18.2k, 300 milliwatts and 600 milliwatts. So we're okay. But we have an awful lot of values, and you know, the tolerancing isn't too good. So let's go back and change this to 0.1. Okay, so now we have a much smaller area of choices here, and we're down here to the 10k area, and we're still back to the 300, 600 milliwatt. And we see 10.2k and 18.7k. We can choose any of these values here. Now, if these aren't in your standard stock of resistors, we can go back and change this to like 0.5%. Let's start, and now we have more values that we can choose on. And then we come down here to the area that you particularly care about, and see if there's anything out there that'll work that you have in stock or that you're willing to buy. So here again we have the 10k and the 18.2, but it has a little bit of tolerance to it. The output voltage is a little bit off versus the 10.2 and the 18.7. So if you want to get a little bit more tolerancing on your output, if you want to be a little bit closer to your ideal 3.3 volts in this case, you're going to want to choose a 10.2, 18.7, or something else that gives you a better tolerancing on the output. And over here we can see the tolerance from the from the voltage divider over temperature. And let's see. We have V out, we have the min and the max. And we go back down here and we can see that the 10.2 case gives us 3.3, a minimum of 3.257 and a maximum of 3.3422. So we can see that here's our spread over worst case. That's extreme value analysis with a nominal of 3.3. So that's how we can use this program to quickly find standard value resistors for a particular voltage divider. The program also allows you to determine R1 and R2 for a standard adjustable three-terminal regulator that follows the same equation as like an LM317, LM317, 117, in that same family. And what you're going to do is you're going to put in the output voltage that you're desiring. Let's say we want 3.3. And the VREF is 1.2. That's the internal reference that we're going to be using that you get out of the data sheet. And I adjust is 10 microamps. Our pass window again is our window of allowable values for tolerancing of the output. And we hit start, and we get a family of values. And you can do the same thing with this to come up with something that will get you the closest values that you want. We can go back and change this to 0.1, and we can see now we have a much smaller family of values. And it looks like since we want to use rather small values for R1, the 107, 187 probably will be our best case, unless we want to have a little bit more, we want to be out of regulation a little bit. So let's put in 0.03 and see what happens. And here we now have more values, and we can see the tolerancing on the output. So we can choose any of these combinations for R1 and R2 that satisfies what we're looking for. And here's the output voltage and the tolerancing. So you can see that this program will provide you with a very fast means of calculating a voltage divider for any given situation. And we use voltage dividers a lot, especially in comparators and in power supplies. We're going to have a reference and a feedback voltage, and we need a divider to get the proper voltage so that the V out is equal to some D ref somewhere. This program also will detect if you're putting in wrong values. It will handle negative voltages. We can change this to minus 5.1 and minus 3.3 and see what happens. And we get a family of values. Works just fine. But let's suppose that we put in a negative voltage and we're looking for a positive voltage coming out. It should give us an error, which it does. It says Vn, V out must be greater than Vn and V out must be less than V2. No solution to this problem, because you can't get a positive voltage from a voltage divider putting in a negative voltage. And there's other scenarios that go in here. It's a 4-quadrant problem, and helps keep you from making mistakes. It will give you errors. That concludes this explanation of how to use ratio. Thanks for watching.